So in this unit, we're going to be learning about how to control congestion in networks. You already know about something called flow control. Flow control is when we try to prevent a sender from overwhelming a receiver by the receiver telling the sender to slow down. Congestion control is essentially extending that notion to the network as a whole. You can imagine that if senders were to send too many packets into the network, they're going to overwhelm the network. The buffers in the routers are going to fill up, the links are going to overflow, and we're going to start dropping packets. Clearly not a very good thing to happen. So congestion control is about preventing the senders from overwhelming the network. So that leads us naturally to ask, how do we do it? What do we want from a congestion control mechanism? First, clearly, it needs to prevent the overwhelming from happening. And the second thing is we generally want it to spread the pain evenly. We want to make sure that all of the flows that are being controlled in a fair and equal way.
So one of the big questions that comes up is we want to control congestion. But how should we do it? Where should we do it? Should we do it at the edge? Should we do it within the network? Well, if we follow the end-to-end argument, right, or the strong end-to-end argument, we would say that we want the network to just forward packets. We want the intelligence to be at the edges. And so that's actually in practice often what's done today. So in this unit, we're going to talk about TCP and how TCP controls congestion. It turns out it's one of its most important features, that a TCP sender and TCP receiver, or particularly a sender, can control how many packets it puts into a network to make sure that it doesn't overwhelm the network. It controls the congestion. And so it's this end-to-end approach, leaving the inside of the network simple. And it turns out you can just do it at the edge, and it turns out you can do it very, very well. So TCP congestion control chose to use a particular algorithm called additive increase multiplicative decrease, or AIMD. And it turns out that this algorithm has a bunch of really interesting properties when you actually look at how it behaves in even very large complex networks with millions of flows competing. It has some very nice stable properties that allow it to control congestion well, and also in a fair way.
Turns out that it's such an important idea. By many, it's considered one of the crown jewels of networking. It's one of the most important intellectual ideas to have found its way into the network. It's in TCP. It's been in TCP now for about 25 years. And so it's a very significant part of controlling congestion in the internet. So in this unit, you're going to be learning about what congestion control is, the kinds of properties that we would like from a congestion control algorithm, what the specific congestion control mechanisms are that are used in TCP, the AIMD that Phil just mentioned. And you're going to be learning a lot of details about how that works, how it's implemented in practice, how it works in different scenarios, what happens when you have one flow, what happens when you have many flows. And you're going to be learning a lot about not only what TCP is today, but it's going to give you a lot of insight into what TCP congestion control might become in the future.